What's going on, kids? Today we're going to take a look at what you need to do if you go out to start your car in the morning, turn the key, and there's nothing but maybe a couple of clicks. So I'm here inside our 2001 Honda Accord, and I'm going to put the key in the ignition and flip it to the on position, and everything lights up. The radio kicks on, I've got headlights, if you can see those kick on. So from where I'm sitting right now, this car should start. But when I go to turn the key, you can hear it tries to start, and you even heard the engine kick over once, and then it just turns into a whole bunch of rapid clicks. That typically leads you to think that it's an issue with the battery. So let's pop the hood and take a look and see what we've got going on under the hood. So the hood pop is here next to kind of by where your left ankle would be. And so I'll pull this back. Hood's popped up. And there's going to be a latch to release it somewhere in the middle. Lift up, pop the hood, and find our battery. The first thing to look at is your terminals, and here's our negative terminal. The connection is tight, no wiggles, and we've got a little bit of corrosion here on this one that can cause that issue. This one isn't terrible, certainly not the worst I've seen, but I will probably clean this up before I put it all back together when we're done. So the battery's there, the connections are good, so now it's time to see if the state of charge on this battery is any good. And for that, we need a couple of tools. So on the toolbox, I've got a digital multimeter, DMM, and a set of jumper cables, and also a jump box that we're going to use to actually get this car to start. But to see why our car wouldn't start, we're going to use a meter and first check our sitting voltage or our standing voltage on this battery to see what it's at. And that's going to let us kind of see why we have lights, but as soon as we try and start the car, we're going to see that voltage drop way, way, way down. That's because this battery does have volts, but it doesn't have the cold cranking amps or the current available to be pushed out of the battery in order to start the actual motor. We'll test the actual current flow coming from this battery in the next video, and we'll test our battery to see how many cold cranking amps are available in it in our next video as well. But first, let's hook up this meter and then try and start the car and see what happens to the voltage. So I've got my DMM here next to the car, and I've got the red lead plugged in here to the voltage port, focus, to the voltage port, and then I've got the black lead plugged into our common ground port. And then I've got a dial on here that's got a whole bunch of different settings for me to measure different things that have to do with electricity. DMMs or digital multimeters are nothing more than a fancy calculator for electricity. And you need to kind of tell it what you're trying to calculate the same way you would in a math class. So with this dial, we need to rotate this over to voltage DC. So there's two different options here. We've got alternating current, which is that wave symbol, and then we've got our direct current voltage here with our solid line and our dashed line. So with our leads plugged in and our meter set to DC volts, we're going to use these two alligator clips to hook it up onto our battery. The black lead is going to go onto the negative side, and the red lead is going to go onto our positive side. Normally you're going to see some sort of cover on the battery positive terminal. So you kind of pull that back, it's usually made of rubber or plastic, and then we'll just hook that on, and now we can read the voltage in this battery. Now, this is sitting at 11.7 volts, and you would think, all right, well, cars are traditionally a 12-volt system. It's actually 12.6 volts of fully charged battery, but 11.7 is pretty darn close to 12, and you would think that this car would still start at 11.7 volts. But let's see what happens when I actually go and turn the key. Actually, before I start the car, I'm going to set this to record minimum voltage. So it's going to stop at whatever the minimum amount of voltage that battery has while I'm trying to start the car. So let's see what happens. So our car didn't start. We heard the engine try and start. It turned over once and then just went to that solenoid clicking, and our minimum voltage was 2.42. Again, when we're at normal kind of steady state, our battery is at over 11 volts. It's a good battery. but there just isn't enough current in it because as soon as you start applying a load to the battery, that voltage drops to 4. So now let's actually see if we can get this thing to start using the energy from another vehicle to get this one to start. So I've laid out a set of these jumper cables. These are pretty decent jumper cables. They're thick cabling. The ones that you get in those like cheap roadside kits for $5, kind of okay in an emergency, but I wouldn't rely on them long term, especially if you have to leave it hooked up for a while if your battery is super dead. The thicker the wire, kind of the more current that they can handle, the better they're going to do with heat. Because we're really just dealing with energy here. So I've got these jumper cables run up to my truck. And notice I have the cables on the floor completely separate. So if you've got a buddy that you can do this with, where they can kind of hold them out hands width apart while you're hooking it up to one vehicle, that's probably the best thing to do. So ideally you want to have your vehicle that runs already running, because we're not only going to use the energy from the battery, but we're going to use the energy from the alternator that's charging the battery this whole time. So with this vehicle running, you would first hook up the cables, keep them separate, and then run your other cables over to the battery terminals on your dead vehicle. You should run, red to red, so positive to positive, and then the negative terminal, you're supposed to hook up to a ground. So the battery ground is just a cable that runs over to the chassis. So any place that is metal on the vehicle, usually a strut top bolt or something like that, is probably a good ground to work off of. If you've got modules or computers hooked up directly to your battery, make sure you run that ground to a piece of metal under the hood instead of just going battery to battery. I've yet to blow up a battery by going red to red, black to black, but it's not the recommended method for jumping a car. So I'm gonna go ahead and start my truck and then hook it up to this side, and we're gonna watch the voltage and see what happens. So again, right now, this battery is sitting at 11.7 volts, but our car won't start. So let's see what happens when we hook it up to my vehicle with the jumper cables. All right, so my truck is running, and let's keep these terminals separate. And here's another thing that I think everybody should know. If you ever watched like a spy movie and there's some sort of torture device created out of DC voltage from a car battery, if I touch these terminals with my hands, I'm fine. There's nothing to worry about when you're dealing with batteries and touching them with your hands. Now, if my hands were made of metal, then that current would be able to jump between those two things, and it would be bad, and you'd get sparks if I ran the two leads together on the jumper cables. But if you keep them separate, you're totally fine. DC voltage or DC current is not going to do anything to you. But again, we're sitting at 11 volts, so let's hook up my jumper cables and see what the voltage goes to on this battery. So now I'm up to 13.9. That's because the voltage coming from my truck, now we're up to 14, which is kind of where I think we should be. A battery sitting voltage is again going to be 12.6 volts, but when a vehicle is running and the alternator is charging the battery, you should see your voltage go up somewhere over 14 to 14.4 volts. Let's jump in this Accord and see what the voltage does when I try and start it now. Again, I'm going to hit that record button so we can see our minimum voltage when I start the car. So we can see our car fired right up. The voltage only dropped to 11 volts while we tried to start it. And our running voltage is 14.5, and I'm going to disconnect these jumper cables, and let's see what our voltage is at now with the vehicle running. Again, keep these separate. I disconnect my vehicle, and now our voltage is still sitting at 14.3. So I'm going to turn this car off and let's see what happens to the voltage when I key it off. So we see our voltage kind of bleed off, and it's going to get back to around 12 volts. And while this car was running for even those, 3 minutes while I was disconnecting the jumper cables, let's see if the alternator pushed enough current to this battery to get it to start again. So that was it. Our battery's in decent shape. It's good. It holds a charge. The battery was just low because I left the lights on for about 3 hours with the radio on before I started doing this demo. Now, jumping from another vehicle is not the only method that you have. These jump boxes are nice, and you can get these on Amazon or Napa or wherever, 50 to 60 bucks depending on how large of one you get, but it's the same deal. You've got a positive side and a negative side. You turn the jump box on, it gives you a state of charge. We can see our voltage is at 12.5 volts. If I hook this up, it will automatically see that it's attached to a battery, and you'll see those lights start dancing. That lets us know that the car is ready to start. And if I check my meter again, with the leads connected, we can see that I'm over that 12 volts. This thing's putting out 12.5 volts. The voltage went up from where it was at before, and this thing will be ready to start. So I guess the moral of today's story is that when it comes to starting a car, there's more to a battery than just voltage. You have to look at the connections, look at corrosion, and then watch what happens to the voltage when you actually apply a load to that battery. Because if your voltage drops well below 8 volts or so when you're trying to start a car, the problem is the battery doesn't have enough current, enough energy to push out of that battery to get that big heavy motor spinning. In the next video, we're going to take a look at measuring cold cranking amperage from a battery using a Snap-on battery tester and also a digital oscilloscope so we can plot over time what happens to voltage as current increases. And we can start talking about that Ohm's law, V over IR nonsense that you learned about physics and thought, when am I ever going to have to use that? The answer is every time you start a car, you're using V over IR. So check back with us in the next one and be good, and I'll see you next time.